We all know that in any industrial control system, there needs to be devices installed that provide protection against damage from overheating for both wiring and the equipment connected to it. Now, this overheating is typically caused by a variety of faults or short circuits and overload conditions in the electrical circuits. Traditionally, we've utilized an appropriately sized circuit breaker or fuse to provide that protection. But with the recent industry shift from 120 volt AC to a safer 24 volt DC as the voltage of choice for control circuits, we've had to develop a more appropriate type of electronic circuit protector, or ECP as they're known, that meet the demands of this low voltage circuitry. Why is that? Well, miniature circuit breakers are electro-mechanical thermal devices that are designed to function on AC power networks that supply an infinite amount of current from a power utility. They're not designed to function effectively in a 24 volt DC power circuit. On the other hand, 24 volt DC power is supplied from a switch mode power converter. It's only capable of providing a limited amount of current based on the power rating of that device. These new electronic circuit protectors operate with a combination of a solid-state switching component and an integrated circuit chip. They're specifically designed to quickly detect short circuits and small overload conditions that are typically found in a 24 volt DC circuit. So, let's take a look at the Allen-Bradley Bulletin 1694 line of electronic circuit protectors. As you can see, it's a modular, easy to install system that's comprised of two main components: a power feed module and the protection modules. The components are mechanically and electrically connected by swing arms, so there's no inner wiring. Connection to the field devices is simplified with push-in style terminal connectors, and there are no accessories required. The power feed module accepts the incoming supply from a 24 volt power supply, and the protection modules provide the individual circuit protection and disconnecting means for each of the downstream devices. There are three models of the protection modules available: single or space-saving dual-channel modules that have fixed current ratings from 1 to 10 amps, and the dual-channel adjustable model that gives you the flexibility to program each channel from 1 to 10 amps in just one device. In addition to the two main components, there are optional power distribution models that kind of act as terminal blocks for connecting multiple devices on one channel or to feed 24 volt power downstream to another control cabinet. As a bonus, the 1694 is offered in two versions. The standard version has basic functionality, manual control, and built-in auxiliary circuits and multicolored LED lights for diagnostics. The advanced version brings your electronic circuit protection into the connected enterprise by providing enhanced diagnostics, flexible parameter settings, and remote reset capability that can be controlled and monitored in your controller and HMI over Ethernet via IO-Link technology. Now let's discuss one very important topic that's commonly overlooked or at least misunderstood, and that is Class 2 power supplies. National Electric Code Article 725 sets the requirements for the elimination of fire hazards in 24 volt DC circuits. It states that the maximum power potential for these circuits be limited to 100 volt amps or 4.16 amps. Many of your field devices that are supplied by that 24 volt power supply are labeled such and required to be fed from a Class 2 rated device. This means that you're not permitted to connect any Class 2 rated field device to a 24 volt DC power circuit being fed from a power supply rated more than 4.16 amps. So for example, the commonly used 5, 10, or 20 amp power supplies are not Class 2 rated devices. Unfortunately, it's often necessary to have one of these larger power supplies in order to handle the loading for all of the low voltage devices in your system. And that's where the 1694 ECP saves the day. The 1 amp through 4 amp protection modules are offered with Class 2 ratings. This allows you to have individual Class 2 circuit protection for any of the field devices that require it, while still being able to size your power supply for the larger combined loads. Finally, I want to show you 4 visual simulations that represent how the Bulletin 1694 ECPs function under different fault conditions in a 24-volt DC circuit compared to that of a traditional miniature circuit breaker. In each of the examples, the performance of the 1 amp rated 1694 ECP on the far left side of the screen is compared to 3 identically sized 1 amp miniature circuit breakers that have different time to trip curve characteristics. The first simulation represents a short circuit and how each device will respond upon initial startup of the power supply. As you can see, the ECP detected the fault and tripped the protector in 0.01 seconds. Because the DC power supply cannot provide enough current for the miniature circuit breaker to operate, it took between 10 to 16 seconds for them to trip. This is more than enough time to potentially cause damage to the wiring or connected devices. The next example is very interesting, and it simulates a short circuit under load while current is actually running through the circuit. As you can see, all of the devices passed the test and tripped in a reasonable amount of time. However, the 1694 tripped much faster and therefore had the best performance. The third simulation is looking at the performance in an overload situation where the field device is exceeding the 1 amp current draw. In this case, the 1694 ECP shut down the output after about 3 seconds, but it takes approximately 3 to 8 minutes for the miniature circuit breakers to trip. The reason for that goes back to one of my opening statements regarding the fact that AC circuit breakers have thermal characteristics that require extended time to detect an overcurrent condition. And in this last example, we're able to see how the 1694's smart device design allows for the high level of short-term inrush current that's required for capacitive charging loads and inductive loads like small servo motors. Only one of the 3 miniature circuit breakers passed the test because they aren't able to differentiate between it being an inrush current or a short circuit. I hope you found that brief introduction to electronic circuit protection helpful. If you want to dig a little deeper into all the technical information and specification data, I've included links to that documentation listed below. And if you'd like to have a live remote demonstration of a working model of the fully integrated IO-Link version of the hardware, reach out to your local authorized Rockwell Automation distributor and make that request.